Hello everyone. Chandana, would you mind confirming me whether I'm audible completely to you?
Yeah, Leela, you are audible.
Okay. So team, due to internet fluctuations at my end, yesterday I couldn't give you the LMS KT. So today I would be briefing you all about the LMS access, and then I'll hand over the session to trainer. Okay. Yeah. So I will share my screen. Chandana, please, confirm me again once it is visible. So it is visible, right?
Yeah, Leela, it is visible.
Okay, I'll go ahead. Team, you can use any of the web browser available in your device and type onlinelearning.excelr.com. Before to it, I believe every one of you who have registered for the program would already been given the LMS access to this particular program. If not, I will show you another way how you can enroll by yourself, or else our team member will share you the registration link again in the chat window. You can use that and register for the program. Our ExcelR team will give you the access by tomorrow by the time you join the session. Okay. So the URL for the LMS platform is onlinelearning.excelr.com. Please make a note of this. It's onlinelearning.excelr.com. Okay, so once you visit the website, on the right hand side, you will see 4 options which include sign in. So, okay, we have to click on sign in. And here you would be asked to enter the email ID and the password which you have set up. In case if you are an existing user of ExcelR, you can use your credentials to set the password. If not, as soon as you register for the program, you might have received an email, and where you will be provided, a link to set the password. In case if you didn't get it, or if you fail to set the password within the time, you can try clicking on forget your password and set the password to your LMS. So here you can click on forget your password and then give your registered email ID. Click on reset my password. As soon as you click on reset my password, you would receive an email again where you would be seeing a link to reset the password. As I already know my password, I'm not trying this way. I click on sign in and give my credentials to log into the dashboard. So I'm giving my credentials of LMS, the password that I have set up. So as soon as I entered my login email ID and the password, I would be seeing this user interface, which has many options available, including home, my library, store, and so on. So the first and foremost thing is I would be explaining you the ways to join the session. So team, the URL for the platform is onlinelearning.excelr.com. Those who have already registered for this program, you might have received email from ExcelR to set the password. In case if the verification link says that it is expired, you can click on forget your password and try setting it up. And then once you log into the LMS, on the first view of it, you will see a banner displaying on your screen. So this is Chandana, am I audible clearly?
Yeah, Leela, you are audible.
Okay, so this banner is for the cybersecurity FTP program. Once you click on this, if you are unable to join the Zoom link, or if you don't receive the Zoom link on time, you can come to the LMS and click on this banner. This will redirect you to the YouTube live happening. I will show you. Okay, so this is how it helps. If you can click on this banner, you will be redirected to the live happening in our ExcelR channel. And then, so coming to the live session joining, you always can check the classroom access that has been given to you, which is nothing but National FDP. 1 second, I will show you here in my list. Yeah, this is the classroom. National Faculty Development Program on Cyber Security, September 2023. Those who have registered and got the access, you all will have the access to this classroom, and you have to click on here on the right hand side. And then you will see the classroom structure, which has two options available. One is curriculum, second one is mid. Under curriculum, you will have three different folders, which includes feedback response, session recording, and the materials. So as of now, we haven't availed the materials. Maybe by today or tomorrow, we will upload the required materials and the materials which are used during the session by our trainer. And coming to the session recording, in which you will have all the day's session recordings available in the LMS, and this platform or the account has no expiry. You can use this LMS account for lifetime. At any particular time, you can come back to the classroom and access the recordings available as well as the materials uploaded. And coming to the feedback response, as we mentioned yesterday, you would be receiving a participation certificate upon your active participation for the entire program. If we see that you have acquired 60% of the attendance of this 15 days FTP program, to your registered email ID, we will send the participation certificate of this FTP cybersecurity. Okay, so all you just need to do is you have to come to LMS. Under a feedback response, you will see a Google form embedded, and it is active in between 4:30 to 5:30 p.m. So during this 1 hour, you can give your feedback. We will consider this feedback as your attendance. At the same time, we consider your feedback to improve our quality purpose. Quality of the training. Okay, we use this feedback for our quality purpose, and also we consider that you attended the FTP program in order to give you the participation certificate. I am emphasizing again that those who have acquired 60% of the attendance throughout the program will be eligible for the participation certificate. Okay, so this is all about the folders that we would be giving you the access. Like, we will be giving you the materials access and session recording access. Along with that, you can submit the feedback to give you the participation certificate. And this feedback link will be shared with you through Zoom chat as well as in the YouTube chat. And I am talking about the people who doesn't have the classroom access in their LMS account. You might have LMS access, but you don't see this classroom available in your LMS account. So for those, you can visit the store option, which is the third option in the LMS homepage. You can click on store, under which you will see multiple products available. Among these, we have listed out this classroom called National Faculty Development Program on Cybersecurity. Those who have LMS access, you need not to try it. For the people who don't see the classroom available in their LMS account, can visit the store. Under store, you will see this classroom, and you can click on enroll now. And again, you have to click on enroll now for the second time and acknowledge it as a proceed. It is for free of cost, so you need not to pay anything. Like, you can go ahead with the order, and now you will be seeing this classroom access in your home page itself, and you will see the schedule available under home to join the live session. Okay, so under home on your right hand side of the screen, down to the banner, under today's session, you will see the schedule available. So to join the live session every day, you can come to the LMS around 2:50 p.m. because the session schedule is 3 to 5, right? So we made it 10 minutes early. So you can visit the LMS at 2:50 p.m. Then you will see an option called join. If you click on join, it again asks you to proceed. And once you click on proceed, you will be landing into the Zoom application where the live session is happening. This is the way how you have to join the session. If you fail to join the Zoom session, you can view the live happening in our YouTube channel by clicking on this banner. Okay, I'll address few questions that I received in the chat. Those who have registered and didn't receive the email, try to register again because you might have entered the invalid email address, or else you may check in your spam and promotion folders of your email to check whether you have been given the LMS access or not. If not, you can again register for the program, then you will be given LMS access. If you want to have the classroom access by yourself, you can visit the store, which is the third option on the page, and you can enroll by yourself. Okay, those who are saying that they haven't received the password link, please try to register again. If not, you can visit LMS and click on forget your password option and try to set the password. Okay, so this is all I have to talk about team, and I wish you all the best. And yeah, I would like to hand over the session to the trainer. Hi, Akash.
Hello, everyone. I hope you guys are doing good. Hi, hello. Okay, so we'll be starting today's session. Thank you so much, Leela, for your amazing presentation about the LMS. I'm sure all of you guys are aware of it now, and all the doubts are clear about accessing the content and the platform. All right, so let's begin with today's session. We have some great topics lined up today, and we'll be discussing on them. First is networking fundamentals, then we'll talk about a few networking devices. Let me just share my screen with you. There you go. Okay, let me also get the chat box. All right, okay. Good afternoon, good evening, good morning, wherever you are according to your time zone. I hope you guys had a great session yesterday and you learned a few things. Maybe I was capable enough. And today we are again going to learn some amazing stuff like what is computer network, right? This is going to be the agenda for today. We'll understand the basics and the introduction to networking. We'll also understand different networking devices and the components of a network, that what comprises in a network, various kind of protocols. I'll just give you a hint of almost all the basic ones that you can understand. And then we'll come to the infamous OSI model. There's one bonus thing that I will explain at the end, so stay tuned for that. Also, my chat box is always available for you all. So in case if you have any questions, any queries that you want to ask, you can put in the chat box. But I just want to let everyone know that at the end of the session, I will be having like a a doubt clearing session with you, like for 10 minutes, right? And if you have any queries, you can ask then. If you have a query in between the session, please put your query in here, raise a hand or something, and please wait patiently for your turn. Yesterday we had a huge amount of it, so that's why we are just clearing it out. Okay, enough beating around the bush. Now let's start the topic for today. Networking, computer networking. So if I explain it in a layman's term, networking is nothing but interconnection between different devices, between different computers, different technologies in your wireless system, right? Just a second. Let me get the whiteboard for you. Yeah. Yes, you have to bear with me and my drawings today as well. All right. So if I say, like, if you go in a nutshell, this is what a network looks like, where your few devices are interconnected with each other, right? This is a network. But it's not just that. There's a lot more thing that happens in your network. There's a lot of stuff that goes on. A lot of new devices are included. So let's understand the basics first. A computer network is a collection of interconnected devices that communicate with each other to share either resources or information. Resources can be like documents, images, videos, could be literally anything. Information is basic data, like maybe text messages, emails, and stuff like that. You know what I mean? Then these devices can be computers, servers, printers, smartphone, or any device capable of connecting to a network. If your device have the capability, it is a part of a network to share information and transact with other devices. So that's what a network is in a nutshell. What happens in a network, you can understand it like, think of it as a computer virtual expressway, enabling a smooth flow of data between various devices until it reaches the intended destination. So if this is device number one and this is device number two, they are sharing information in one way or the other. How they are sharing this detail, what all things are involved, and what protocol set of rules are involved, that is what we are going to learn today. And whenever two devices are connected and creating a transaction, it's called a network. That's what it is. Now, network is also various kinds. There are four major types of them. Okay. These are the four major types: the LAN, WAN, MAN, and PAN. I know they sound funny, but yes, they are important. Let's understand them first, and then we'll talk about it. So a local area network is nothing but just your traditional network that I just showed you. If you have device 1, 2, 3, and 4, and they are interconnected, they are in a small comprised space. They are in a local area network. Maybe at your home, not at the office actually, at your home is the right answer, is the right example for that. If you'll read it further, it covers a limited geographical area, such as home, office building, or a campus. Oops. Yeah. Yeah, okay. So a home, office building, or a campus, like in your colleges and universities, you have a small area where interconnection is configured. So that's a LAN. It allows devices in close proximity to share resources. Close proximity. They can, if they are far away, the category changes. Okay. If they are in a close proximity, it's a LAN, local area network. Okay. They're commonly used in households and small businesses, just like a single shop or something like that. On the other hand, the wide area network is completely opposite to it. It's for the large geographical distances, which often connects lands. Okay, give me a second. Yep. All right. So if this is one of the lands that we are talking about, right? And this is another land somewhere else in your state or in your city, that can be land number two. If they are connecting to each other, you see, now the devices are not connecting, the LAN is connecting to another LAN. So when this kind of connection happens, it's called a wider area network, because now the area just expanded, right? It spans in larger geographical distances, connecting different lands over different cities and countries. The best example is the internet. The internet is the largest and the most well-known example of WAN. So when you're connecting to the internet, you're connecting with various devices on the internet, like different web servers, cameras, and stuff like that. And that's an example of a WAN. Now, this thing, metropolitan area network, frankly speaking, is very irrelevant, according to me, personal opinion. But again, it falls somewhere between the wide area network and the local area network, somewhere between that. So it's not as big as a WAN and not as small as a LAN. So it's like that. So it falls between LAN and WAN in terms of the geographical coverage. Okay. That's where it falls. It typically spans a city or a metropolitan area connecting multiple LANs. Again, same as the wide area network, but not as big as the wide area network, a little bit smaller than that, maybe in a town or maybe in a small city. So mans are generally used by organizations who have multiple offices in the same city, like in the city of Delhi and in the city of Gurgaon or in Noida here. So if a company has offices in all three spaces, so they can be connected over a metropolitan area network, a MAN, not a WAN. A wide area is even bigger than that. So it's a whole different ball game. Now, the fourth one is one of the most commonly used. We use it almost every day. It's personal area network. I'll give you a simple example and you'll understand your Bluetooth connections. So when your phone connects to a Bluetooth speaker, it's actually forming a personal area network. In fact, your TVs, your smart TVs or whatever kind of TV you have, if you're having a remote control to connect with your TV, it's using infrared connections to create a personal area network. So that's also the same thing. If you have a universal remote that controls everything in your home, then it's also forming a personal area network. So that's a PAN. It's a smallest type of network, usually catered around an individual's device. So if this is a phone and the devices are there in this net are connecting to this device in specific only with the help of close proximity range technologies like infrared radio signals or Bluetooth, then it's a personal area network. That's what it is. So that is the difference between the types of networks. It's not such big of a deal, frankly, regular stuff, normal stuff, but it will help you understand how a network is configured and how it's working. We're going to learn a little bit more than this. It's just the basic stuff. Next we have is the topology. Now, what's a topology, if you may ask? It's nothing but an architecture. Architecture on how the network is built. So it refers to the arrangement of devices and communication links in a network, that how the devices are connected. Yes, it matters actually how your devices are connected. You cannot just arrange them randomly and call it a network. I mean, it's a network, but again, you need a certain kind of arrangement for monitoring purposes, for data relevancy and data protection purposes. So for a lot of reasons, basically. So as you can see here, the topologies are required in terms to provide advantages in terms of performance, scalability, and fault tolerance. Fault tolerance. This is when you ensure that your network is really efficient and appropriate and not causing any kind of traffic. So that's why it is needed. Now, let me quickly explain you the topologies. There are four major kind of topologies: star, bus, ring, and mesh. Okay, I'm going to repeat: star, bus, ring, mesh. Simple. I'll show you the diagrams as well and like how they look like, so it stuck in your head. So if you talk about a star topology, consider 5 devices I'm going to take. All right, device 1, device 2, how about device 3, device 4, and device 5. Okay, and let's now connect each other. So the interconnection looks something like this. You see what I'm doing is I'm just connecting all the devices with each other. But right now, not all devices are interconnected. If you will see, device number 2 is not connected to 4. So let's do that. We can also see device 5 is not connected with 3. 3 is also not connected to 1. 1 is also not connected to number 4. 2 is not connected to number 5. Do you see something happening here? In the center part, in the central part, you will see a star formation. And that's why it is named as such, a star topology. Here, every single device you can see is interconnected to each other. 2 connects with 1, with number 5, number 4, number 3, right? Similarly goes with all the other devices. All of them are interconnected. So here the communication is open. Everybody can connect with anyone they want, right? A bus topology looks somewhat like a bus seating arrangement. If you have ever been into a public transport, the seating arrangement is very uniform and very specified. So consider this as your router where you're getting the internet from, and this can be considered as the interconnections. So device 1, device number 2, number 3, number 4, and number 5. So here comes a cable, another one, another one, another one, and there you go. You see here, what's happening is all of them are connected to a single cable, you see, which is this one. But at the same time, they are arranged in a certain fashion that they are in an alternate method. This way, they can ensure the division of the devices, and a certain architecture is created that can be maintained easily. In general corporate scenarios, you will see a bus topology very oftenly. This is one of the ways. And if you ever go to a call center, this is the kind of topology they prefer because it's easy to manage, easy to monitor, and a single cable works for all. So that's how it is. A single channel works for all. I'm sorry, it's a single channel, and then there are branches coming out of it. So a single channel works for all. That's bus. If you will see, it's almost like a bus seating arrangement, like seats are divided up and down. So that's why it's called a bus topology. Next, we were talking about this thing called a ring topology. Very simple, frankly. I'll show you. Again, the same number of devices, number 2, number 3, number 4, and number 5. So all of them connects in such a way that this kind of a connection is present. Now, in this case, it's forming a ring, right? And that's exactly what it is meant by a ring topology, wherein all the devices are interconnected, but not with each other. There's let's say if a packet is supposed to be sent from device number 2 and the destination is number 5, so it have to go through the whole process, a whole route from here, either from here. If 2 needs to send it to 1, either it can directly send it from this side or from this side. So there are multi-directional transactions that can take place, but there is no direct transaction here. So I'm sorry. So this is a good example where you want someone to be in between a communication. So the routing can be very tricky in this part. If you go by the theory here, you will see a ring topology, each device is connected precisely to 2 other devices. You can see this is how it looks like, right? 2 is connected to 1 and 3, so on and so forth for all the other devices, forming a circular network. Data travel around the ring from one device to another until it reaches the destination intended. So it always follows the circle. This way, all the devices are going to receive the packet that is supposed to be delivered, because that is the route they are going through. Ring topologies are less common in modern networks due to limited scalability. You cannot scale it to a bigger network, right? Because again, let's say there are 500 devices, and imagine if you want to send something from device number 238 to device number 431. It's a real long circle. It's going to take a lot of time and a lot of resources, which doesn't make sense, right? And what if any device stops working? Then the data packet is never delivered, right? So ring topology is really, really obsolete. Okay. Okay. Next is the mesh. Now I'm going to show you something, and you will quickly judge me and call me a real bad artist, but I need to show you this. Number 2, number 3, number 4, number 5, number 7. Oh, I missed number 6. Let's put it here. Now I'm going to make a connection. You will see something like this. It looks like it is designed by a psychopath, isn't it? Like somebody who have a real good vengeance against the company. And yes, we have seen this kind of stuff. 5 directly connects with 6, 8 directly connects with 7, with number 1. Number 1 directly connects with number 6, number 4 directly connects with number 7. So you see what's happening here basically? It's a mess, isn't it? Right? All these cables are interconnecting with each other. There's no uniformity, no such maintenance, and that's why it's called a mesh topology. It provides redundant connections between devices, ensuring multiple paths for data transmission. The redundancy improves fault tolerance and network reliability. Yes, I know it looks real messy, but it is more reliable. Isn't that funny? That the most messy thing is the most reliable kind of connection. It improves it because one single device connects with all of them. There's no such pattern to follow, no such kind of rules to follow, but it can just, transact with any other device at any point of time. And that's one of the best ones so far. However, mesh topologies can be complex, no doubt, costly, again, no doubt, primarily in large networks. We're just talking about 7 devices here. Imagine this for 700 devices, right? So, and this kind of a network is literally intolerable. And when people like us have to work with it, it's a real pain. Now, this is an example of something we called a closed mesh. Okay. Mesh. It's a closed mesh. Now, there's another variety of mesh which looks something like this. Again, I'm going to take example of 7 devices. But the interconnection is a little bit different here. So you will see something like this. That's it. Now you see not all of them are connected, but it's still a mesh. Okay. And this kind of a connection is called a open mesh, where some devices are like, openly connected to a few of them, but it's still a mesh, but it's an open mesh. And that one is a closed mesh because like all of them are interconnected. So it's like a closed circuit happening. Here, there are a few devices which are openly available. So that's why it's called a open mesh. 2 different types. It's not that big of a deal. I'm just explaining for the sake of the variety, so you know about it. So these are a type of connection that exists in a network. Again, only 4 type of major connections are there. I'm going to repeat: star, bus, ring, and mesh. Now you know about it, okay? You're not going to forget, because you have seen it. Visual references are always good. Now the thing that we're going to start is definitely going to, maybe for those who are beginners, haunt you a little bit. because it's a little complex to understand the differences in the devices and their functionality, especially when you have never used it. Trust me, when I started my CCNA course and curriculum, I never used the devices and they used to scare me a lot because I really couldn't understand the difference. Now it's a whole different process, but again, just from telling from experience. Okay. Now we are talking about the networking components, the devices and the components. These are the elements which actually form the network, which help you to form a network, by the way. They play a crucial role in enabling communication and data exchange between computers. Now let's see what are the key components of a network. The first key component is called a network interface card, which is NIC. Consider this as a brain of a computer or an ability of a computer which helps them connect with the internet. Without an NIC, without the network interface card, you cannot connect with a Wi-Fi or a network at all. This hardware allows a computer or any other device, for that matter, to connect to a network. You might be wondering some way that how does this computer have that much brain to connect with the network? It's because of this NIC. I'm going to show you for a visual reference that how does it look like. See it here. Yep. So this is how an NIC looks like. These are the computer NICs. They are present in all your devices, by the way, from your smartwatch. If you have a smart AC, an air conditioner, or maybe a refrigerator, or even a vacuum cleaner, these days everything is smart. Even if your toothbrush connects with Wi-Fi, it have an NIC. It cannot connect without the NIC, and that's why it is really important. NIC is a hardware, okay? I'm specifying it because it's going to come handy in the upcoming sessions. It's a hardware entity. It have also an identity of its own. And it's a crucial component because without it, you cannot connect with the internet or network for that matter, for any kind of network. Okay. Next, we have two things: switches and the okay. All right. Just give me a quick second. I don't remember making this kind of change. All right. Just a quick second, guys. Okay, that's much better. Okay, we have two things: switches and hubs. Let's understand the hubs first, okay? Now, think of a hub as an old-fashioned signal repeater. It repeats the signal, okay? Consider it that way. When data is sent from one device connected to a hub, it broadcasts the data to all the devices connected to the same hub. I'm going to show you how, okay? Just wait. So in your network, consider you have a few devices. Right? Now they are all interconnected with something called a hub. A hub looks like this. It have a few LAN ports. I'm going to make just a couple of them. Then there's a reset button or something like that. There is another port, which I'm not going to talk about right now. I'll explain that later. Now consider that your devices are connected to these ports, right? The problem here is that when, let's say that device number 3 from here wants to send something to device number 1, okay? It sends to the hub. The hub redirects that traffic to device number 1, like this, right? But that's not the case. Actually, hub is so stupid, sorry for the use of word, but it lacks the intelligence, and it start broadcasting the data to all the devices. That means there is no privacy. If device number 3 is connecting with a hub and it sends something to another device, it goes to all the other devices as well, unnecessarily, right? I'm sure none of you would want that to happen. That is why we don't use hubs anymore. Hubs and switches almost, I'm going to say it again, almost looks the similar. I'm going to show you for a visual reference at how they look like. A comparative reference will be better. Okay, this is good. So you can see this is what a hubs look like, and that's a switch. The number of ports, you can see switches have a huge amount of ports availability. Hubs are limited, but again, hubs are stupid because they just broadcast it to everyone, and we don't want that, right? This approach leads to more collision and reduced network efficiency. Understand, if there are 400 packets that is being sent to one device, right? Like in this case, if 3 is sending 400 different packets to device number 1, now they go to all the other devices as well. 400 here also, 400 here also, right? Now the problem is it just increases the traffic. The efficiency is not there, right? For 1200 packets are there right now in the network unnecessarily, right? This makes it highly inefficient, and it also increases the traffic in the network, due to which the communication is not that better. Hubs are now less common in modern networks. Switches are largely replaced the hubs. Now let's understand what is a switch, right? Now a switch sounds a little better. It is actually is. It's a smart traffic cop. It have a brain of its own. So when computers or devices connect to the same network with each other, switch intelligently, mind it, forwards the data directly to the intended recipient only. So 3 sends something to 1, it goes only to 1, nobody else, right? Nobody else, unlikely the hub. Unlike hubs, switches create dedicated communicating channel. It creates a dedicated channel between the two devices. So isn't that good? It makes it faster, more secure, more reliable, and better. Simple, right? More efficient. That's what we want, right? And switches are expensive, by the way, guys. You can get cheap switches which cannot be monitored. So it comes in two varieties, basically. One of them is managed switch, managed and unmanaged. Managed switches are a little bit more expensive. They are used in corporate sectors. If you want one for your home, maybe for like around, I think 6 to 8 ports, you can get the unmanaged switch. It's as cheap as maybe a couple of $1,000. It's that cheap. So yeah, managed switches are really expensive. They may go somewhere around 20, 30, 40K, depending on the brand that you're buying for. So yeah, that's the difference. But they really help you monitor the whole network. So you can understand it this way. How, I mean, I'm claiming that you can monitor. So I'll tell you how. Imagine this is your router at your home. I'll explain what's a router in a few minutes. Right? Through this router, you connected a switch with, let's say, 3, 4, 5 ports. Okay. Now, all the devices are connected with these 5 ports. Your management becomes really easy. You can dedicate channels between devices because it's a switch. You can monitor the data traffic very simply. You can install certain kind of firewalls on a switch, not on individual devices. You can directly install it on the switch so that whatever traffic is coming from the router, it first gets into the switch firewall, and then it gets, the data can be transacted to the other places. So instead of installing security on all the devices, you can do it directly on the switch. Isn't that good? right? So what you can do is, let's say you have 4 devices. I'm just giving you a rough example. 1, 2, 3, and 4. You can install a firewall kind of thing here. I'll explain what these kind of things are. This firewall is designed in such a way that the dedicated channels are going to all the devices. It goes to number 1. There is another dedicated channel that goes to number 2. Another channel goes to number 4, and another one goes to number 3. So this way, what's happening is, whenever data transaction is coming from the router, it first goes into, let me make it a little bit bigger so you can see it. It first travels into the firewall, and then according to the destination address, that where the packet is supposed to go, the firewall verifies the packets, see if anything is wrong, and if everything is good, it will redirect the packet to the dedicated channel. If it is supposed to go to 1, it directs to number 1. If it go to number 3, it directs to number 3. So this way, switch makes it a hell lot easier for me to manage and protect my network. Isn't that good, right? So that's what companies do. They install switches, big switches, huge amount of switches, so that they can monitor the network efficiently and better. So that's the difference between a switch and a hub. We are going to now understand the difference between a router and a repeater. We have heard this term a lot, routers. What are they? So here I explain them as a traffic cop, right? Routers are the navigation systems that guide the data packet between different networks. A router operate, okay, let me explain it here. Okay, so consider it this way. You have an ISP in your local area, right? Who gives you the internet, who you're paying for the internet, by the way. So that ISP is providing it to so many devices, right? And I'm just considering right now in your city, this is your big city, okay? Big city. And there is one ISP here who provides the internet to a lot of homes. Now, every single home have their own routers. And every router is, serving a lot of other devices, which are your devices. So this is consumer number 1. Router 1 have, let's say, 3 devices. Router number 2 have a few more. Number 3, number 4, and number 5. Interestingly, if you'll see, this is network. This is a local area network that is being formed here, right? This is your city. This is your ISP through which you and a lot of other devices are getting their Wi-Fi connections. So the routers are the one which connects with your ISP and gives you the internet further. Now, you might get confused between two things, which are a router and a modem. Almost similar stuff, okay? Routers have the functionality to provide you the wireless signals. Routers can do both. They connect with ISP and provides Wi-Fi. I'm just explaining in simpler terms so that everybody can understand. But modems have a very simple job, right? They only connect with ISP and provides internet. They don't give you the Wi-Fi, by the way. On the other hand, routers do both the stuff. It gets the internet from ISP and provides you Wi-Fi. But if you have a modem, so either can be this way, your ISP that connects to your router, and from your router you have Wi-Fi. It's either this way, or it's this way where your ISP is connecting into your modem Your modem connects to a router and your router gives you the Wi-Fi. It's either of these two ways. Now let's understand the difference. Here, the modem's duty is to take in the analog signals that are coming from the ISP, which are electrical signals, by the way, analog signals. It takes those signals that get into the modem and they get translated into digital signals. The one that you have in your router for internet, right? They're digital signals, right? Zeros and ones. That's what computer understand, digital signals. It doesn't understand electrical stuff. So modem have the duty to change that stuff. If you go by the definition of modem as well, I'm going to explain the rest of the stuff, don't worry. Modems are short for modulator and demodulator. It's a device that allows the digital devices like your computer to communicate with analog systems. Your phone lines or your ISP lines have analog signals. It translates those signals into digital ones, and that's why it's called a modem. Mod and MO from the modulator and DEM from the demodulator. So modem, that's what it's called. Okay, modems convert digital signals from your computer into analog and vice versa, analog to digital. So it's like a translator between you and the ISP. Now, these days, modems are rarely seen because we are all using routers in our places, right? Routers do the both stuff. They also have this modulation and demodulation function inbuilt. So you just simply connect your fiber cable or your ISP cable into your router and you get the Wi-Fi. Simple stuff, right? So that's what a router does. If you will see and understand this city and example, a router is connecting a home network to the ISP, right? And let's say this is, okay, understand this example very carefully right now. Here is device number, I call it D3, okay? This is D3. If D3 wants to connect with K5, how is the connection going to take place? D3 wants to connect with K5. So what's going to happen is, understand it very carefully, guys, please. Okay. So first, D3 sends a signal to your router. The router then connects to your ISP. The ISP connects to the router R1, and R1 sends the signal to K5. So you see the whole route. D3 does not directly connect with K5. It doesn't happen like that. There's a whole route it have to follow. And this route decides where the packet will go and how the packet will go, actually, not where. Because the destination was already assigned at D3. D3 already assigned that I want to go to K5. There could be any location. It gave the address and everything. And that is how the packet traveled to K5 directly with the help of the routers and the ISP. If there is another device here, let's say X4. So if D3 wants to connect with X4, again, the same thing. It goes to the ISP. ISP connects with R2 and R2 gives it to X4. That's how the packet transaction takes place in a city. If you, of course, you need to have the address for the K5 and X4. You need the addresses. Otherwise, how are you going to send? It's almost like a postal service, you need the address to send a letter. Same stuff happens here. Now that we have understood that. Yeah, okay. Repeaters are simple stuff. You know what a router does. It connects to the internet. It helps you connect with other devices on the internet. That's what a router does in a nutshell. We'll understand more with the few more examples. We're talking about repeaters right now. Simple stuff. Let's say this is your router in your home, okay? And the Wi-Fi strength is only till 10 meters. Example stuff, okay? But again, you're really fortunate and you have a really big house or you work for a big company and a few devices are here. But again, there are devices here as well. Then what? What are you going to do? You are going to use this amazing thing called repeater, install it somewhere here, and it will amplify these signals to an even further distance. This repeater right here is going to amplify those signals to a broader distances. So if you go by the literal definition of it, it says repeaters are network devices designed to extend the reach of network's physical connection. So if a network is only limited to 10 meters, it can extend it to 40 meters as well. Some strong repeaters can do that. Some cheaper ones and the normal, like the domestic repeaters that we have, they can extend it to at least like 5 to 7 meters, which is pretty good actually. When data travels across long distance, it can lose the strength and clarity because the longer the distance, the lesser number of packets can reach it, the more time it will take, leading to signal degradation. The signals start degrading. Obviously, if you go away from your Wi-Fi, you might be going to your, I don't know, to the loo or maybe somewhere in your bedrooms as well. Sometimes they have weak Wi-Fi connections. You can use repeaters, install it somewhere in your room, and it will just amplify the signal for you. So yeah, it helps to maintain the integrity of data as it travels over long distances. Repeaters are good, basically, right? They're good people. You already know about the modem. I just explained that to you. We also understand the gateway. Gateways act as intermediaries between different networks, acting as the translator. Now, this is not a hardware, frankly. They can be a hardware. It's very complex. They come in both flavors. It is also a hardware. It can also be a software. Okay. A hardware gateway is supposed to be installed. A software gateway is supposed to be, I mean, just installed inside a particular device. Okay, I'm sorry, I blundered. A hardware gateway is supposed to be connected to your router or to your modem, whereas a software gateway just need to be installed on your router or the switch, actually on the router. So what do we do is the gateway converts data from one format to another. So if the format incoming is different, it converts into something that I can understand and then delivers to me. It makes sure that information can flow smoothly between networks with distinct characteristic. So if I have some sort of encryption or some other kind of translation, gateways can make it work for me and make it feasible for me to understand what kind of traffic is coming in. When I will teach you a little bit more about network scanning and network hacking, I'll explain about the gateway thing as well, how gateways can be hacked. I will show you one of the examples for this. So you can wait for it for a better understanding. Okay, so we are done with the components. We are done with the basic stuff. Now we are going to just do a level up. Okay. Right. I'm going to also a little bit speed up here so you can understand, but please try to cope up. We have almost an hour. Actually, I can extend it a little bit more. Okay. Protocols. What is meant by the word protocol? A protocol is a set of rules and conventions that enables computer and devices to communicate with each other. Okay, hold on. I see a few people are not understanding gateway as of now. It's okay. I'll explain it with a practical example in the upcoming module. I think day after tomorrow, I'll be teaching you network hacking. I'll show you the example of gateway hacking so you can understand the practical implementation of it. The theoretical, I know it's a little bit complex to understand that you cannot, as I said, you can't understand a device until unless you know what it does, right? You have never seen it, you have never used it. So I'll explain it with a practical understanding so it will be a little bit better. Okay. So please just have a little bit of patience. Okay. Protocol. A protocol is a set of rules, right? That defines what you can do and what you should not. It defines a certain procedure that you should follow. That's a protocol. In network, data delivery is not just done randomly. There is a protocol. There is a set of rule for this. that you always have to follow. There are many set of rules actually for various kind of data packets. First set of rule or protocol is TCP IP. Now, let me open my favorite thing, whiteboard. I just love this thing. Okay. We're talking about this thing called the TCP. There's also another thing called a UDP. I'll explain them both together so that we can save time and understand better. Okay. TCP and UDP. If you go by the literal definition, TCP is transmission control protocol, whereas UDP is user datagram protocol. Okay. I'm not going to draw all this. I'm just going to type the names. Okay. Yeah. So TCP is the foundation of the internet and most modern networks. It breaks data into smaller packets. I'll explain how it works. So consider this as a big chunk of data. Right. So this is a big chunk of data which needs to be sent from device number 1 to device number 2. Okay. It as of now resides on device number 1. So what TCP will do is it will divide this into 3, 4, 5, 6, 7, 8, 9. These 9, this 8-bit data, it will divide it into smaller packets. Something happened to my stylus. Actually, I need new batteries for this. I'm so sorry. Yes. Okay. So sorry, guys. Just a second. Okay, it works now. All right. Okay. So as of now, it resides on the device number 1. TCP protocol will divide this packet into smaller chunks and will send these chunks one by one on device number 2. On device number 2, a reassembly will take place for this big chunk, and that is when it is delivered. So before sending it, it divides into smaller packets, send it to the other device, and reassembles it there. But why does it do that? Why? What is the need? Why is TCP a psychopath? No, actually, it's very smart move because this way it is ensuring no packet is lost. If he sends a big chunk, and what if it get lost, right? But if smaller chunks are sent, they can be managed easily, they can be categorized, they can be monitored, they can be counted, and it does not take a lot of your bandwidth to send smaller packets. If you send a bigger packet, it takes a lot of your bandwidth of internet, but smaller packets take smaller bandwidth. So that's why it is better. But there is a big but here that says it is going to take time. So in a nutshell, we can understand that TCP is time taking. Deva. So TCP here is time taking. That means it is slower, but it is more reliable. because it is ensuring that no packet is lost. That means you can rely on it, but it makes it a little bit slower, right? On the other hand, when you talk about UDP, UDP is faster. It doesn't work with the criteria of TCP. It sends the complete chunk one at a time, right? So that's why it is faster. But there is a big problem. As I mentioned in TCP, that packets are divided so that there is no packet loss. Because if you'll send bigger packets, there will be a packet loss. That is why UDP is unreliable. Oh, God. So it's unreliable. It's faster but unreliable. It's slower but it's reliable. That is the basic difference if you understand. It's another protocol used for data transmission, but it's faster and more lightweight than TCP. It's commonly used for real-time applications. See, when we are doing video calls, we often see there are some sort of lags in between, right? The video call stucks, or in games, when you play online games, you see something called as a ping response, which is basically the response time coming from the servers. There we can still, accept a little bit of data packet loss, but in TCP, there is no data packet loss. Imagine that you're downloading a file from the web server. And if it is coming from UDP and there is a packet loss, so the file is not downloaded properly, right? Imagine you downloading a video and you cannot see a few part of the video, right? That is not acceptable. This is why for general purpose usage, we always use TCP. Although it is slower, but it's reliable. We will receive the complete packets all the time. But in other functionalities like video streaming, online gaming, we can accept a little packet loss because we can still see the stream properly. We can still see the other person, and it makes more sense to use it there. That's why. Mr. Burnaton have a question. I think he is raising his hand. You can please ask it in the chat box. And Mr. Moria says, if I can explain in Hindi, I am so sorry. This content need to be explained in a language that everybody can be on the same page, and I prefer Hindi. I'm a Hindi speaker myself, but if you understand, like for professional reasons, I have to communicate in English so that everybody's on the same page. That's one of the languages everybody understands. So I'm sorry, I cannot explain in Hindi, but if you want me to repeat something, you can let me know. And instead of raising hands, you can directly put a question in the chat box. I'll be entertaining all of them. So when somebody asks you how your packet travels, now you know that TCP is responsible for it. TCP actually breaks it down into smaller chunks and send it to the recipient. And UDP just sends the whole thing. UDP is a badass. He don't care. Next is HTTP. Some of you guys who revised what I taught yesterday, they know it. HTTP. Remember, I taught about HTTP and HTTPS yesterday itself. What they do is web-based transactions. This protocol is used for web browsing. Okay, Satvika is asking how UDP is considered lightweight than TCP. See, in TCP, there is an additional functionality added. In both the places, in TCP and UDP both, data transaction is taking place. So that is something common, right? But in TCP, there is an additional functionality that breaks it down first. And on the recipient end, it combines it, right? It recollects the whole thing. So that additional functionality makes it more heavier, makes it more resource consuming. That is why UDP is lightweight. It doesn't use that kind of stuff. Just data transaction at the tip of your fingertips. So that's how it is. So that's why it is more lightweight than TCP. By the way, just for your research purposes, you can also look into something called as a Quick, QUIC. I'll explain about it. Let me get the article for you. You can also do a Google search, by the way. It's kind of like a combination. It's a hybrid between TCP and UDP. It was founded back in 2012, but trust me, not a lot of people know about this. If I am your interviewer, I will definitely ask about this, and I'm pretty sure you will fail because you don't know. So a quick protocol is a hybrid of UDP and TCP. It have the the speed of UDP but reliability of TCP. So both the good parts in one protocol. And funny thing is, still we are not using it because the use case is very broader and there's a lot of experimentation going on about it. So maybe in the next decade we'll see it. But yeah, so Quick is not that broadly used till date due to some some what do you say? Due to some issues, I think that's the right word. Yeah. Shortcomings. Yeah, shortcomings. That's the right word. Sorry. Okay. I'm just a human, man. Come on. Give me a break. Okay. So we have already discussed the TCP, UDP, and HTTP. We did this yesterday. HTTP is hypertext transfer protocol. It helps connecting your web browser to the web server, and all the data transaction can take place. When you type a web address in your browser, it uses HTTP to fetch the content and display it on your screen. So yeah, it's amazing. Next is the DNS, domain name system. It already says about it, domain name system. It is the system for your domains, right? Now, I haven't explained you about this thing called an IP address, but kindly just understand it as a identity. Okay, it's like your PAN card. If you're an Indian, you'll understand that, right? So this like you have an identity, your name, which is your primary identity. Maybe in a company you have an identity called employee ID. Your biometrics, your fingerprints, retinal scan is your identity. Similarly, on the internet, IP address is one of the identities, one of the most important identities. Okay. Every device, mind it, every single device that connects with the internet have an IP address. Obviously, your computer have an IP address, but when the computer connects with a web server, I told you yesterday, web server is nothing but another computer, which is somewhere else, remotely hosting a web page. Okay, Venkat have made a question. I'll explain this at the end of the session. Don't mind it. Uh, so both of them have their own IP addresses, right? It have an IP1. I'm going to name it, and I'm going to name this IP2, because ultimately a web server is also another computer, which is hosting that website. So when on your browser you type this URL in the browser, it could be like google.com or whatever. This URL was created, this kind of URL was created for our understanding, because we humans are, very naive creatures. We don't understand numbers, because computers talk in numbers like 001, 0111, 000, right? We can't understand that kind of stuff, can we? Or for that matter, can you really remember big IP addresses? You cannot remember all of them because they are also numbers. So for our better understanding, a conversion, a translation was created between the IP address and the domain names. So an IP address is converted into a domain name, and vice versa takes place as well, so that the computers can also understand what is being requested by understanding the numbers. And we humans can also understand what are we requesting by reading the domain. So this way a translation is taken place. And guess what? Who takes care of this translation? our very own domain name system. It translates. It acts as a phone book for internet, making it easier for us to access websites without remembering long strings of numbers. We don't have to remember them all. We can just remember google.com. It's simple, right? But if I have to remember the IP address, it's going to take ages. So it's better to remember a domain. We understand words better than numbers. So that's the DNS. There's a lot of things involved in DNS, frankly speaking. There's a lot of other elements. I'll explain you this when I'll teach you web application hacking. I'll explain you what is DNS. There is going to be a module on information gathering. I'll also explain DNS there. So there's a lot of things about DNS that need to be explained, and it cannot be explained in a few minutes. It will take a few time. So let's keep it for then. Then comes a DHCP. Now it is very interesting one. Okay, so pay attention. When you connect to your router, your devices, let's say call it D3. It's one of the device. The router is giving one of the IP address. But how does the router know to what IP address should be given? If there is also D5, there is D6, there is D8, right? How the router actually knows? Does router have a brain of its own? No, it actually not. It has something called as DHCP, Dynamic Host Configuration Protocol. The name says it all. Dynamic host configuration. Dynamic host means like the number of devices that keep on connecting to your network. DHCP automatically assigns an IP address to the devices on the network. Automatically, it have a pool of IP addresses. When I'll teach you about IP address, I'll show you how an IP address is assigned. That's a whole different ball game. But let's understand what is DHCP. It makes it easier for users to connect without manually configuring the network. We don't have to do it. We don't have to assign it myself. The DHCP will do it by its own. When you connect to a Wi-Fi network, for instance, DHCP gives you an IP address so you can communicate with the network. So your identity is provided to you, your local identity is provided to you by your router's DHCP. Your ISP DHCP gives you a identity for the wide area network. See, understand this. You have a name, okay? You have a name and you have a nickname. Your name, my name is Akash, right? I may have a nickname or an alias name that people call me at home, and that could be, I don't know, Lucky, right? So now the point is, in my local network, that is my home, this is a name that will be considered as a valid identity, but this name cannot be used in the in the public, right? If I'm going to my neighbor's place or maybe some other city, some other state, I have to give my proper legal name, my name, Akash, right? I cannot say Lucky. They don't know Lucky, they know Akash. So these are two different identities, a local identity and a wide area network identity. So it's a public IP, private IP. Private IP is in your own network, public IP is in the wide area network. That means on the internet. So that's a different identity that is getting you from the ISP. Your ISP gives you one IP to your router. Okay. That defines you as a person in the city. If you understand it in this example, I explained it here. Just a second. Oh, I removed all of it. Anyway, no problem. So your ISP gives you an IP address. That is your identity on the internet. But again, your devices in your home, they also need an identity, right? So, and local IP is assigned to them so that you can identify what devices they are in the internet. And you can also identify with their IP address. So that is the whole point of it. And DHCP is the one which is managing all that. So he is basically doing a thankless job, but it's a very important job. It saves time, basically. Next, we have ICMP, Internet Control Message Protocol. Now, this is very interesting as well. Okay, I'll explain this way. When a single device, let's say D1, is connecting to D2, okay, they both are in the same network. They are not connecting with each other, but they're in the same network. I'm just calling it NT. How will D1 know that D2 is also existing in the same network? How will it know that? We do something like a ping, you know, a ping is sent on D2. I'm going to show you how to do it. Simple stuff. I'll open my command prompt. There you go. And I'll ping one of the IPs in my network. Okay. And I'm getting a response. That means the device exists. When I'm pinging this IP, it's giving me a response. It's giving me a reply. You see, that means the device exists. Otherwise, how will it give a reply? Let's say if I ping maybe 186. What does that say? Destination host unreachable. That means this device does not exist. So this pinging process, the process of pinging a device in your network, is done with the help of ICMP, Internet Control Message Protocol. It is ICMP is a supporting protocol that helps manage network errors and diagnostic. It also helps you manage the errors and diagnostic. If there is an error on device one, it broadcasts it to two other devices. Like if there is a if the device is not available, not reachable, or probably having a lot of traffic, that kind of diagnostic is also managed by ICMP. It is used to check if a device is reachable on the network or to report errors when data cannot be delivered. When data is not delivered, it delivers the error, and that error delivery is done with ICMP. Just like I get it right here, destination host unreachable, right? I'm going to show you this in Linux. Linux shows it a little bit better. I'm going to show you right here. Please don't mind all this thing. This is just an example for you. So please just focus on what I'm teaching and not the other platform and everything. So if I ping another device, okay, oops, okay. Linux shows me a little bit better. It shows me the ICMP sequence. This confirms the presence of ICMP protocol. You see, ICMP sequence 1, 2, 3, 4, and 5. These are the number of packets it is sending on the recipient. So it's getting a reply from the recipient as well. And this ICMP sequence confirms the presence of the ICMP module or ICMP protocol, right? So this way we can confirm the ICMP exists, and it is the responsibility of ICMP, Internet Control Message Protocol, to check if the device is reachable and to report errors if the data cannot be delivered. So that is the job for ICMP. Okay. Next, we have this amazing thing called OSI model. Okay. Quickly as well. We have a lot of time remaining. Okay. OSI model is like a blueprint for how computer networks should communicate with each other. Okay. See, frankly speaking, I can explain the same module, whatever document I'm teaching, for even 5 hours. I can take it even, I'm not kidding, I can even take it for 10 hours. But the point is, we have a limited time where I have to finish it. And I'm trying to explain you as much details as possible with as much examples as possible. OSI model in itself is a very big concept, which I'm trying to explain you in a summarized way so you can understand it and relate to what is happening here. Definitely, networking is not something that you can learn in a single day. It takes a lot of practice. It takes a lot of, assessment. So please try to cooperate with it. and understand that you need to put your time into it and learn about it. I'm here just to give you the idea, the understanding, the fundamental details about what is the components, what are the protocols and the architecture. But again, it involves a lot of more stuff which you need to work with. So when I'm talking about OSI model, I'm just going to give you the structure of it. I will not go that in depth so that it starts becoming unrelatable. I'm just going to give you the relatable details here in a layman term so that everybody can understand. So I hope you will be on the same page with me. Understand what is OSI first. It's a model, like a blueprint on how computer network should communicate. It defines that how they should communicate. It's like a layered process which defines what should come first and how the network should be, proceeding further, how the connection should be proceeding further. So we'll start with the very first. Oh, my bad. Start with the very first layer here. There are total 7 layers you can see on the left side. Total 7 layers, starting from the physical to the application layer. I'll explain one by one all of them. Starting with the physical layer, it is the foundation dealing with physical connections and raw data transmission. It handles electrical signals, cables, and network hardware like switches and routers. So in this layer, your routers, your switches, your hubs, repeaters, everything comes. This is where the packet have started to communicate further. Okay, this is where the internet connection is beginning. Your cables gives you the internet, right? So that's a physical layer where all the physical connections are taking place. After the physical layer comes a data link layer. Now here, what happens is device linking takes place. It uses MAC address to ensure data reaches the correct recipient. Now you don't know MAC address, I'm going to explain that quickly. Just like every device have an IP address because it is given by your network, right? But what lets you connect with the network? Remember the network interface card, right? This is the device that lets you connect with the network. If this is not there, you will not be able to connect with the network in the first place, right? So my point here is, apart from the IP address, you should have another identity which defines or identifies your hardware. It's a hardware identity. IP address is a network identity that is given by DHCP by your network. But MAC address is your hardware identity. It is the identity of that hardware called the NIC. Every NIC have a different MAC address. It cannot be repeated, cannot be duplicated, but IP addresses can be duplicated. They can be repeated. There is a possibility for that. MAC addresses cannot be. They are static. They never change. Once you have a MAC address, it's going to be with you till you destroy the computer. It's going to be there forever. So that's the difference between the IP and a MAC address. So in data link layer, your network first identifies the MAC address. So when the packet is generated from here, it goes and check the MAC address of the recipient, that if it is going to the right place. First, it will check the MAC, that the hardware I'm connecting with is appropriate. Next, in the network layer, it checks the IP address, that if it is actually in my network. So two things happen. First, it checked the hardware, that who am I connecting with. Then it checked the IP, that is this the right network I'm connecting with or not. And once both of them are verified, that is when it proceeds further. So packet always goes through all these verifications first. It first of all connects with the physical layer, your router or wherever you are connecting with. Then it checks your MAC address, that if you are the right person I want to go. And for a double verification, it also checks your IP address to confirm that, this is the place I want to go. After the verifications are done, the packet goes into the transport layer. That this ensures a smooth delivery and reliability. You read this line here, it breaks data into smaller chunks and check if everything arrives correctly. Does it sound relatable? We have heard this before, right? It's a deja vu kind of thing. TCP. On the transport layer, we have TCP working. TCP works on transport layer. It basically facilitates the transport layer to deliver the data to the corresponding address. It's like splitting a big message into smaller envelopes and make sure nothing gets lost in the transit. So data transmission takes place on transport layer. Transport layer sends the data to the desired place, wherever the destination address is. Now, once the transportation have started between two devices, let's say if device 1 is sending something to device number 2, the device 1 have initiated the transport process. So there should be a communication between them, right? In device number 1 and device number 2. Like if I want to send you something, I need to connect with you first, right? I cannot send you directly, but just by thinking, I cannot select. I cannot send. By creating a session between both of us, I can send you something. So that's what happens on level number 5. It creates a session. A session is initiated. Here we can establish, manage, or terminate connections between different applications. So let's say WhatsApp, okay? I am having a WhatsApp and you have a WhatsApp. So we need to have a session first, then only I can send you some data packets, right? So this is just an example. It could also be taken as an example for for a protocol. It's called FTP. FTP is a protocol that is file transfer protocol. And I really don't need to explain what it is. It says file transfer. So obviously it is used to exchange files between different systems, right? So here you will transfer files from one place to another. But FTP needs to be on both sides, of course. Just like I need to have WhatsApp, you need to have WhatsApp. Similarly, I need to have FTP, you need to have FTP, and a session will be created, and my file can be shared to your location. So that is how the transaction takes place. So FTP is one of the protocol for file transfers. So here the session need to be initiated from device number 1 to device number 2. Application here can be considered as FTP. It's like opening and closing doors for communication. So on the session layer, on layer number 5, the communication actually establishes, the transport layer just defines that, okay, I'm ready to send anything, but the session layer defines where I'm sending and if the connection is open or not, if the door is actually open to enter or not. Once everything is confirmed, oh, oops. I'm sorry, guys, just a second. Okay, yeah, better. Much better. There was a misalignment. I'm so sorry about that. Okay. After the session is established, transportation is in process, verifications are done, we come to the presentation layer. How the data is going to be presented. Did I send you a document? Did I send you maybe an image, maybe a video, an audio file? What exactly did I send, right? So if one have sent an image file on number 2, the presentation layer defines that how the data is supposed to be presented on the recipient end. It is responsible for translating data into a format that applications can understand. So in case of our FTP, the presentation layer defines what kind of file is being received, right? If it's an image file, it's a video or document or Excel sheet, PDF, whatever the format is. So it defines it on the presentation layer. Think of it as a translating different languages so everyone can communicate. It's just like that. Finally, when everything is done, your verifications are done, MAC address verification, IP verification are done, transport layer is initiated, session is established, presentation is defined that what kind of data I'm going to receive. But again, where am I going to receive? I'm going to receive it on an application. And this is where the applications takes place. Like on WhatsApp, when you send the data, it goes through all this process and then it shows up on your WhatsApp screen, and then it will show on your FTP as well. If when you are sending from FTP to FTP, the transaction will take place and it will show you at the end on the application layer. This is the final layer. We reach the top floor where all the user applications reside, your email, your web browsers, file transfers, and more. This is where you interact directly with the network and use the services provided. So this is where you directly interact with the data that is coming in. You can see it, you can read it, you can edit, modify, delete, whatever you want to do. Whatever interaction you want to do, it happens on the application layer. You cannot interact with the data when it's in the network layer or maybe in the data link layer. I mean, you can interact with them, but the process is very different altogether. But on the application layer, the user interacts with the final result, the final packet that is received. So these are the 7 layers of OSI model that defines. I mean, so Santesh is asking if there is any shortcut to remember. Frankly, I can tell you a mnemonic or something like that, but trust me when I say this, it doesn't help you when you are in an interview, because interviewers do not want a mnemonic. They want an understanding. They want you to know if you they want to know if you really understand the concept of OSI model or not. Because I have seen a lot of candidates I have interviewed for bigger companies like PwC and Deloitte. I've worked there myself. So I know what they require and I know what they will ask you for, and I know how they're going to judge you based on what you're saying. So if you're going to work with a mnemonic and just going to ratify some stuff, it will not work, trust me, because they will ask you questions which will be conceptual based and not theory based. So you need to understand that just understand the life cycle. You don't need a mnemonic to understand your life cycle, right? You don't need to know, like, we all know that we are babies, then we become teenagers, we become adults, we become man, and then we can become old, right? There's nothing to remember here. We know the concept. Similar concept is for a packet. Just remember it the way it is. Remember the cycle instead of just the words. We're not here to just ratify some stuff. We are here to learn stuff, so learn it instead of just ratifying it. I personally don't recommend that kind of stuff. I will send all these notes to you. Don't worry. Everybody's going to get it. Everybody's going to get it. On your LMS, you will have it all. Okay. I'll share with the team. They will send it to you. So with the end of this OSI model, we are done with today's content. And I told you about the bonus thing for today, right? Here is the bonus, guys. On your screen, you're going to see this thing. This is like a little assessment kind of thing I created for you all, especially for you all. So you guys can go on to this website, menti.com right now, or scan this QR code from your phones or something. It will open a page where we'll be interacting with some of the questionnaires that I have prepared, right? So I want you all to go to the menti.com and enter the code 3178-8671. I'm going to share this in the chat box as well. Go on the website and enter this code so you guys can also participate in the Q&A. Menti.com. The code is 3178. (8671). Come on, everyone. And I want participation from all of you, please. Okay, this is going to be really interesting. So we're going to do some questionnaires. We will understand that how things work, and you'll also be able to interact with the questions. You guys can go on this platform and just connect with it. Please react at the bottom. You will see at the bottom there's a reaction as well. So I will get to know that how many of you are actually connected. Three 178 8671. Okay, connect with that one. I can see people coming in. So I'm going to show the first question right here, and I want all of you to participate in it. Which device operates at the data link layer of the OSI model? Data link layer. Come on, everyone. I will see the results that are coming up here. A few of you are actually participating, which is really good. So most of you guys are saying switch is the device that is on the data link layer. Okay. All of you are actually going for switch, huh? I can see a lot of results. I'll request everybody to please answer on the menti.com page instead of in the chat box. It'll be better. Okay, time to show the answer. I see we received a few responses. Not all of you are participating, which is really sad, but it's okay. I appreciate the participation here. The correct answer is switch. So yes, 56 of you are correct. So awesome. Good job. You understood the concept. A lot of you now are voting in as well. Okay, going on to the next question. Which networking protocol is used for secure file transfer? No. Secure file transfer. FTP is just file transfer that works on HTTP, by the way. Secure file transfer works on another one. I'm just giving you a hint. Okay, a lot of you guys are rooting for SSH, which is really good. Okay, a lot of good responses. 63 of you says SSH. Time to reveal the answer. The answer is SSH. That is absolutely correct. Good job. Next question here comes up. What is a primary function of a router in a network? Read the answers correctly and choose it. What is the primary function of a router? Okay. Almost all of you are going for it. Okay. Okay. Oh, we have the highest bid on the second option here. Okay, fair enough. Oh, I can see the participation just increased. I'm so glad. Good job, guys. Okay, let time to reveal the answer. The correct answer is second, connecting two different network segments. A router connects with two different devices, as I just told you, and I showed you with a visual representation. So moving on to the next question. First of all, good job, guys. Great going so far. Which tool is commonly used for network scanning? Okay, we can skip this question, guys. I'm sorry, I haven't taught you this yet. But a few of you are already going for Nmap, which is good. But we can skip this, okay? Now, the question is, which OSI layer is responsible for routing and logical addressing? For routing and logical addressing. Logical addressing. Remember, I just showed you the OSI model, right? The 7 layers. Come on. Go for the right answer. Okay, most of you are actually routing for network layer. Okay, fair enough. I can see really good participation. Good job, guys. I'll appreciate if all of you will participate into this. None of you are being judged, by the way, okay? I don't even know who is timing the right answer or the wrong answer. So even if it's a wrong answer, you're learning something. So don't worry about that, okay? You can participate. It's free. Right? Okay, time for the right answer. which is network layer. That's correct. Next question, guys. Okay. Now, this is a text-based question. Okay. What is the term used for unauthorized access to a network or a system? What's a term which we use? It's a single word answer. Okay. Go for it. People are saying hacking a lot. Intruding, hack. Okay. Unsecurity. Okay. Hacker. We see a lot of new stuff. So the major term that people are choosing for is hacking, which is really good. That's the right term, hacking, exploitation, that is the major term that we have to stick to. It can be synonymous, exploiting, hacking, intruding, compromising, all these are the same stuff. So you got the idea that what exactly it means. When you are hacking into a network or a system, you are basically compromising it. You're making an unauthorized access, as it says in the question. Time for the next question, guys. Good job on this one, by the way. What protocol ensures secure communication over the web? Secure communication, okay, guys? Okay, a lot of you are saying HTTPS. Amazing. Okay, a few of you said TCP, but it's okay. No problem. You're going to learn pretty soon. HTTPS, that is the correct answer. And I'm very happy to see that a lot of you have understood this. I'm glad I was able to deliver it. Somebody really did said slap. Okay, kindly avoid the profanity here. We are all in a civilized environment. Okay, I'll appreciate that. So HTTPS is the correct answer, guys. Good job on this. What is the name of the device used to forward traffic between network endpoints? Endpoints are nothing but devices, okay? So what's a device? The name of the device, guys. Yeah. A lot of you are saying router. Routers. Yeah, okay. That's the right one. Actually, that's the right one. We already understood. Router is the right answer. Router is used to forward the traffic between network endpoints. So we got the answer correct right here. All right, good job, good job. Amazing. You guys are getting it. You guys are great. Next question, already answered. Wow, okay. All right. Which networking device is used to connect multiple network segments and make forwarding decisions based on MAC addresses? Again, understand the question, guys. Device used to connect multiple network segments and make forwarding decisions, managed decision. Remember something? Rings a bell? Managed and unmanaged connections. I just, changed the language here, but it's the same stuff. The correct answer is switch. And a lot of you got it right. Switch is the right answer, guys. Okay, good job on this one as well. Appreciate that. Okay, the next question is, what type of network attack involves sending a large... Okay, I haven't taught you this. Okay, we can skip this one. I'm sorry. Okay. Which networking protocol is responsible for assigning the IP address dynamically to a device on the network? Come on, this is simple, right? I made it too easy for you guys, I guess. Sharmila and Bhavani, I'll really appreciate if you can put it on the... your answers are correct, by the way, but if you can put it on the Menti, it will be really good. And a lot of you guys are saying DHCP, which is the correct answer. So congratulations, you are right, and you understood the whole concept. Next question coming up. What does the acronym VPN stands for? I taught this yesterday, right? So it shouldn't be that difficult. That's correct, Sharmila. And yes, almost all of you are correct. It's virtual private network. Good job, guys. Good job. In the OSI model, which layer is responsible for error detection and correction? Error detection. It's very simple, guys. Come on, come on, come on. Okay, time for the correct answer, guys. Data link layer. That is correct. Good job, guys. Amazing stuff. Which network scanning technique is involved to send a single ICMP request to range of IP addresses to determine if they're active? Oh, even before I finish the question, you have started answering. Great. This shows you have actually got the understanding of the concept. Amazing stuff. Ping scanning. Almost all of you are correct. A few people are still going for port scanning. It's not actually. It's a whole different thing. See here, ICMP is involved. So I specified about ICMP is involved only for ping scanning. Port scanning is a whole different process. Banner grabbing is also different. ARP is based on ARP, as it says, the address resolution protocol. So the correct answer is ping. That's right. Next question, guys. What is the primary role of a VPN tunneling protocol? Why do we use VPN? I taught this yesterday, right? It's not going to be that difficult. Okay. That's great. All of you are correct. Absolutely correct. Next question, which OSI layer is responsible for session establishment? This is not going to be difficult, is it? I made it too easy. I really went too easy on you guys. I should have been a little. Okay, in next sessions, I'll make the questions even tough. I want to see how good you guys really are. Okay. That's right. You all know it. The session layer is the correct answer. So good job, guys. Next question. What is the process of converting a human readable domain name into the IP address? What is it called? Amazing. Amazing. Good job. Good job. Did somebody just say Vindhyasri? That's correct. Domain name system, the DNS. That is the correct answer, guys. Great job. Awesome. DNS basically do the translation between the domain name and the IP address. So that is the correct answer. You guys got it. Next question. What is the process of converting an IP address into the corresponding MAC address? IP to MAC. I'm not sure if everybody will be able to tell this, but ARP is the right answer. I haven't taught this yet. I'm so sorry about it. I added some questions which I couldn't complete today, but it's okay. We can skip this one. But yes, ARP is the right answer. I'll cover it in the next session. No problem. All right. Well, what's the next question here? Is that it? Okay, yeah, that's pretty much it. That's all. Thank you so much, everyone, for joining the session and answering these questions. I hope you enjoyed it. And these kind of communication will keep taking place in the upcoming sessions as well. I am glad you are able to understand and able to answer the questions correctly as well. So in the next session, we are going to learn a little bit more interesting stuff. I'll teach you network scanning. I'll teach you information gathering. I'll teach you a lot more different stuff, which will be helpful for you to understand newer concepts. And yeah, that was all from today from my side. I really hope you enjoyed the session today and you learned something new. You will use it wisely and you will keep on revising. So that's it from my end. You guys stay safe on the internet, take care of yourself, and stay hydrated. I will see you guys tomorrow, same place, same time. This is Akash Sharma, and have a great day ahead. Over to the ExcelR team. Thank you.
Yeah, thank you, Akash.
You're
It's a
welcome.
wonderful session.
Sure. Thank you.
Yeah.
Right.
Hi, I'm sharing the attendance link again in the chat box. Please mark the attendance, make sure. I hope there is no more questions. If you have any doubt means please let me ask. I think no more questions. Okay, we'll end the session.
All right then. Have a good day,
Yeah.
everyone. Cheers.
Yeah, bye. We'll meet you on that tomorrow same time.